Hello and welcome to the Quantum Science Energy Research Facility. My name is Phase Aviation and today I will be showing you how to operate the Project Helios, or Foxtrot-9 as it is called in game, mobile nuclear fission reactor. The Foxtrot-9 reactor is a fictional Type 247 Stirling converter reactor, which has been said to produce up to 3.5 megawatts of energy. Currently, we are in the briefing room for the reactor, which is inside the reactor's control room. We'll go ahead and move over to the control room itself now and get it started. So, in order to get everything started, what you'll preferably want to do first is come over here to your converter pistons and switch all 4 on. They're not going to do much for now, except make the synchronous go lag horribly. Don't worry about that. At least, not until you get up to a decent temp. Your relief valves, you don't really want to touch unless you just absolutely have to. Like, say your pressure's too high or you've got too much thermal power. Other than that, if you just really need to lose a little bit of temperature or pressure, you can hit them. But I'd advise not to do so for too long. Over here on your left side, you'll have three gauges. One that you especially want to worry about whenever you're raising your control rods. So you'll have your neutron rate, your reactor temp, and your reactor pressure. The one you really want to worry about is your neutron rate. As you raise your control rods, this will slowly start to raise, or quickly if you raise all of them at once. That's the reason why you want to worry about it. If it starts to rise up too high, you'll start to have a high neutron flux, 8% or more, and then it will automatically scram. You don't really want that, because then you kind of have to, start over, and who really wants to do that? But anyway, if you want to, as you're bringing this up, you will monitor this, and as it starts to get to 6, bring it back to neutral. If you want to push it, you can bring it to 8 and then neutralize it. As you can see here on the system overview, our fuel assemblies are all cold at 75 degrees Celsius, and our pressure is about 1060 psi. Our control rods are all the way down and are waiting on us to do something. What we're going to do is we're going to select them all, so they're all selected, both here, there, and out there. We're going to turn on continuous CR transit, which allows them to move not just 5% at a time, but however much you want until you stop, or it decides it wants to scram. And you're going to move your control rod speed to 2 times. 1 times is only 2.5% per tick. 2 times will be 5%. What we're going to do now is we're actually going to start raising this. Note your neutron rate, 6 to 8. 8 is if you want to push it. So if I see, got a quarter out of that already. Let it come back down. Start bringing it up again. Usually I can get about a quarter out of this before I have to neutralize the rods. more. I'm gonna go ahead and try for 20% right off the bat. Yep. See how I got up to about 10%? Not too bad. But 20% will give you enough speed for the temperature to reach a safe operating temperature fast. Not too fast, but fast enough. I've always used done 20% for that reason. Once you get to about 700, you'll want to lower it to about 35 to 40%. As you can see, we're only at 660. Pressure, it'll look like it's starting to get red here, and it will, but you'll want your pressure about 3000 psi. That seems to be kind of the Goldilocks zone with these. Notice the synchronoscope has stopped and is actually starting to lead. Notice our pressure. So we're going to start moving to 40%. And I like to turn off.
Hey, quick announcement. I need the weekly report for the DMR by midnight. Thanks.
Anyway, I like to slow down the control rod speed to 1 times, so that way I can get more precision. And then 42.5. Whoop! That's another thing. Want to make sure your transit is off, just in case. Notice how the pressure is getting too high. $3,400. 3,500 is too much. So you'll start opening your relief valves just in case. Give it a couple seconds. Shut them again. What you want to do is you want to get pressures, like I said, about 3,000. And you want your temperatures, at worst, to be below 900 Celsius. Notice how our pressures and temperatures are going down. That's good. Energy production is maxing out at 15,000. That's for now. So we've got good temperatures. We're going to swap over to pressures, see which one is a little too high. That would be all of them right now. But that's to be expected. I'll look over here. They're not spinning at the same speed. Pressure is coming up again, but that's alright. I want that pressure to be not too much, but not too little. You'll have to adjust your insertion rate accordingly to these, especially your hottest and your average pressure. That's how it's starting to slow down a little bit. Not slowing down a lot more. you want is that once your synchronoscope is within 1 Hertz to sync. Now it's really slow, which is good. Ah, hell. That's going backwards. Too little pressure. Looks how slow. Ta-da. And you are now technically on the grid. Note that once you synchronize, your pressures will drop a bunch. I'm looking at about 700 to 800 pounds dropped. Now you can actually start raising your control rods. I know it'd be faster to go too high thermal power. Alright. So we're not dealing with that problem anymore. What you want to do is manage your sectors in order to maintain a decent pressure and temperature. At this point, the one thing you want to worry about more is temperatures. Green? Good. Greenish kind of yellow. But our worst sector so far is only at 850 and dropping. So what we'll do is we'll deselect all of our rods. We'll select the center rod, I, India, and we'll bring it down a little more. I like to have my center rod down 2.5% more than all my others. And then I'll bring them up a little bit. If I have to, I'll adjust it a bit more accordingly. E is 847, take. Notice how it's stabilizing around here. Bring them up another 2.5. Make sure they don't go too hot. Also note your energy production is around 15,000 kilowatts. That should do it. At least for now. If you want, you can get a little more detailed and start heating every cola sectors, but that takes a lot of practice and a lot of patience, so to speak. Because You'll also have to cool down your hottest sectors because they will heat up. Next, see here, A3, A sector, is starting to get too cold for my likings. I like to have mine around 800. 850 if I can, but 800 at least. So I'll bring this one up. So that's kind of slowly coming up.
Attention all facility
Now,
personnel. This is a friendly reminder that on August
moving on
21st,
to
Wednesday night,
an
we will be
overview
hosting a
of
movie night
all
to watch the
controls.
newly released movie Back to the Future. If you would like to join us, please contact Vanessa Williams at Sector A reception.
Thermal overview, you normally won't be able to turn anything on or off here because you would have to be a supervisor in the maintenance team. I am not. I am only a maintenance personnel. But you would have, I believe you'd have to be able to disable the safety system, which I'm not authorized to do. And then you would have to be able to do these, which you can't seal with the safety system online. However, thermal, these are your pumps, 1 and 2, in and out, in and out, and these are your actual pumps. So, well, moving on to the next panel, reactor settings, neutron rate. Again, remember I told you to keep an eye on this. 6 to 8, remember. And then usually 10 is about the worst you can get. Anything higher than that, and it will start to scram. Reactor temperature. Reactor pressure, which is in pounds per square inch. Right around here is basically your Goldilocks zone. And the reactor safety system, which, again, supervisor or up. Continuous CR transit and control rod speed. We discussed this, but I'll discuss again. Turn this on, they move until you neutralize it. Or if they go to 0 or 100, they will neutralize by themselves. Keep that off for more precision. 2 times control speed, 5%. 1 times, 2.5. Reactor scram will drop all the, will release the control rods from their current position, and they will fall down to 100%. Here on status, it will, instead of saying idle or inactive or moving, it will say grav. It will say grav drop, or gravity drop for short. Reset scram. This can only be done with the temperature below, I believe it is 300 Celsius. But once that is once it's below 300 Celsius, you can hit the reset button and it will re-grab onto the control rods, and then you can move them again. It also has a little bit of delay because, yeah, quantum science. This is your reactor overview switch. Switch between temperature and pressure. Ink, which is good. And it'll take a second for it to cycle. Features, good. Alarm acknowledge. If you've got an alarm going off, you can mute it here. Rod controls. This is what I've been playing with while we get this started. You can do global, none. And if you do none, it'll switch to individual. And then once you have it on individual, you can select which ones you want. Up and down. That's pretty much simple. Your annunciators. I'll get to those here in a second. Your converters. These are what convert your thermal or your heat into power. Notice I'm pulling about 2,400 each and dropping. So what we'll go ahead and do for now is virtual A, come down a bit with it, global, those will come up some. And you will have to manage those quite a bit. Unfortunately, it's not exactly just science, it's nuclear science. It's not rocket science, but it's close. But anyway, the converters, same thing for this for the next screen, 3 and 4. 1 and 2, it'll show you your status, whether the piston is connected down below, and how much that piston is producing. One and 2 are connected to converter loop 1. 3 and 4 are on number 2. And in order to have to be able to close these converter loops, you have to shut off both pistons on that loop, and then you can shut it off. Once you do so, a warning will show on here showing that that loop is closed, or here for this loop. Relief valves. This is where you can control your relief valves, whether they are on or off, and what sectors they will cool down or depressurize. 1 controls A and B, 2 controls C and D, 3 E and F, 4 G and H. There is no relief valve for I. And then your grid synchronization. This is where you will synchronize with your grid or desynchronize. In order to desynchronize, you will have to lower your thermal output and your energy production below 1,000 kilowatts per converter. So you'll have to be about 4,000. Right? Average generation must be lower than 1,125. So, whether that is per converter or total, I am not 100% sure. Anyway, getting on to annunciators. Normally, you'll be seeing about just a small amount of annunciators lit. This one will always be on unless a supervisor has somehow disabled it. Grid synced, well, that's because of this. Control rod gravity drop, that's if you've either pressed the scram button or if it has auto scrammed. And when this is lit, when this is lit, that'll be lit, and a few others will be lit as well. Reactor purge, and I want to say the relief valves will be open as well because of the scram. Anyway, continuous TR transit enabled. That's if you've got this switch turned on. See? Let's back off. Anyway, the ones you want to keep an eye on the most would be grid synced, continuous transit, low control rod insertion, high neutron flux, which if that's going off, that's fixing a scram anyway, high system pressure, or high thermal power. You don't really need to worry about low thermal power unless you're actually trying to generate power. Control rods in transit, that's to let you know if these are moving. Reactor purge and reactor scram would be lit up together. That's obviously if it's scramming. Control rod fault, if you're trying to move a control rod and it isn't moving, that'll light up, an alarm will go off, and your best bet would be to scram the reactor. These are to let you know if your relief valves are open. That's to let you. That one is to let you know if you have a disconnected converter piston. And one of the few things you really don't want to ever happen, reactor rupture, because then you will start losing your feed water, and it'll go basically nowhere. And then before you know it, you're out of water, and you have radiation and a meltdown. As such, if that ever happens, you might want to start running. Anyway, that's your annunciators and kinda a nutshell. And since some people have been talking about it already, yes, there is a secret door right here. In order to activate it, there is a white button on this plant and on this pot right here. It's hard to get out, but if you hit the button, it'll open up. Coming in here, and there's not really much. There's a computer, there's shelves, a dolly, nitrogen and helium tanks, a bucket, a door that actually does not work to the reactor's underside, an elevator that's supposed to go to Epsilon 8, a crate full of Project 238 fuel, and on the reactor, on the elevator, you can either go to Foxtrot-9 or Epsilon 8. Anyway, considering the auxiliary power just died, I would assume that, yep, we'll be fine, but we are not connected to the grid, actually. We are connected to, who knows? But anyway, it's been half an hour. Once again, I am Phase Aviation. This is the Quantum Science Energy Research Facility, the Foxtrot-9 reactor. And this has been how to operate it. more specifically, this has been how to get it up and running and get it on the grid. Anyway, I'll have a good. I hope this video has been helpful, and have a good day.